All right, everybody, let's tackle this piece here. We're dealing with on Tuesday, Thursday today, we're dealing, this shouldn't say solving inequalities with logarithms. That's just goofy. We're just solving logarithms with properties. That should say properties. So we already know some basic things like this. Yeah, you just don't know that the reasoning why or a property. You more know it based on inverses. So if we think about this, any log of 1, so log base anything of 1 is always 0. And if we kind of look at this, if I get rid of my brain just went dead. Yeah, so basically the idea is this: if I get an answer of 0, and what we're saying is I'm plugging in x equals 1, and if we look at a graph of a logarithm, the base point is always 1 and 0. So if I plug in 1, I'll automatically get 0. So that's kind of the idea behind this property. It's based on the graph that anytime the x value is 0 in is 1 in a logarithm, the answer is 0. So log base 2 of 1 is 0, log base 5 of 1 is 0. So then if we move to the next one, you kind of look at this and go, okay, log of the same base. This is our inverse operation. We have base b and b. So those are the same. So they equal 1. So it doesn't matter what it is. It's going to be log base 2 of 2. That's going to equal 1. And so they're exact inverses of each other. So we end up becoming 1. So log base 3 of 3 is 1. Log base 4 of 4, that equals 1. So those are the basic properties of logarithms. And really, if we look at this based on a graph, if I say log base 3 of x, remember we have main points of 1 and 0, and the base and 1. Well, if I plug the base in, if I plug 3 in, so that means it's going to be 3 and 1. So it's really based on the graph. When I plug in the base, I get 1. When I plug in the base, I get 1. That's the whole idea of the main points of the graph. So now we talked about the product property, and let's just kind of remember these are inverses of exponents. So when I take an exponent and I go x squared times x cubed, you guys do x2 plus 3, and that's going to be x equals 5. Okay? So we look at it the same exact way, except we look at it in reverse. When I add logarithms, I multiply the insides. So the log base b of x plus log base b of y really means the log base b of x times y. So when you add logarithms with the same base, you actually multiply. And the arguments are just your x values on the inside. So your ideas on the inside. So if we look at this one, the log base 6 of 3 plus the log base 6 of 5 is going to be the log base 6 of 3 times 5. And that's going to be log base 6 of 15. This one, we look at this, same idea. We have the same base, and we're adding, so we multiply. So we get log base 3 of 2 times x, and so we get the log base 3 of 2x. So we're just kind of using our ideas of what we had for exponents and making it the same. So the idea is the same idea here. If I was dividing exponents, this is x to the third divided by x squared, we subtract it and we get x to the third minus 2 up top. So since I'm subtracting, I'm dividing. So when we have same base, you divide the arguments. So in other words, log base 2 of 12 minus log base 2 of 4, I'm going to take 12 divided by 4. And we're going to get 12 divided by 4. And then that's going to be log base 2 of 3. Okay? This one is kind of a different little setup, but just remember that a coefficient in front becomes the exponent on top, and the exponent on top becomes the coefficient in front. You can go either direction. So in other words, if I have this 3 log base 2 of x, I can move the 3 to the top, and I get log base 2 of x to the third. Same thing going backwards here. I have an exponent. I can move that one in front, and I get 2 log base 3 of y. So it's useful to kind of work either way. You just don't know which way you need to work with it. So we can, and that just depends on the problem. So you move the argument in front, or you move the coefficient and move it to the top. So this one here, we're going to move the x out front, and we get x times log base 2 of 5. Okay? So the change of base property allows you to put things in the calculator, and that's just literally splitting into 2, where the argument on the inside goes on top and the base with the log goes on the bottom. So this will be turned to log base 6, log base 5. This would be log base x and log base 4. Okay? So that makes it easy to put it in the calculator, and we use this one because the calculator has only the log function. There's no base to it, so we can't find log base 5 in the calculator, but we can find log 6 divided by log 5 in the calculator. It just lets us use the calculator, that property. So let's tackle some of these. So we're going to use this idea of solving equations. We're going to solve equations using the properties of logarithms. And so we are adding. So we're still working SADMET, but you got to really watch out. So the number one thing you want to do with logarithms, if you have 2 of them, is you want to condense. So we want to condense. We'll call it condensing. So step 1 is going to be condense, which is going to be for us kind of the SADMEP kind of part, or not the E. It's more of the sim. And so this condensed part is going to be these first 3. And so what we end up with is we're adding here. So in our properties from above, we know that when we add logarithms, we multiply them. We get log base 2 of 4 times x equals 3. That's a 2, by the way, guys. And then now I've condensed and I did my add and subtract. Now I'm working with my exponents in parentheses. So I've done my first part of SADMET. And so what's my inverse operation of log base 2? It's base 2. Those cancel, and I get 4x minus 2 to the third. Sorry, guys, my brain just went dead. And then I finish it up here. I can divide both sides by 4, and I get x equals 8 divided by 4, x equals 2. So those are my problems that I get right here. So it just depends on what we're dealing with. So let's just kind of look at this. This one's a little uglier, right? So I've got a coefficient out in front, So my first step is to get rid of that, because if I divide it over here, it doesn't do any good. So I'm going to move that to the front, so I get log base 2 of x equals log base 2 of 32. And you can notice that these are the same on both sides, but you can look at it this way. How do I get rid of log base 2? I do base 2. Those cancel. Oops, there should be a 5 up there, guys. Sorry, I moved the 5 up there. Remember, I moved the 5 to the top up there. So then I get x to the 5th equals 32. And then how do I get rid of this 5th power? I'm going to do root 5. X equals root 5 of 32, which is actually equal to 2. So we still have all our old skills we got to deal with, which makes the problem a little tougher, but you guys kind of get the idea that the new logarithm pieces are the same idea. We just got to deal with the properties. So let's tackle this one, which is one little step at a time. We know we have a coefficient here. So I got log base 7 of x squared, because I moved the 2 to the top. And then I've got this right side. I'm adding, so I'm going to be multiplying. So now I'm going to be multiplying 2 times 27. And so that's going to end up being log base 7 of 3 times 27, which is 81. I got 81 by multiplying 3 times 27, just so you guys know. And that's where I got 81 from. And now I've got the same logarithms on both sides, which makes it nicer, because when you have them on opposites, it's really ugly. So we just take base 7. It's going to cancel this out, and I get x squared equals 81. Take the square root of both sides. X equals plus or minus 9. Okay? So that's our basic idea from it. One of these won't work because you can't use a negative number based on that. So that should be x equals 9 only. Because remember, when we're dealing with logarithm graphs and we draw it, we don't want anything, no negatives, unless it shifts sideways. No negatives. All right. So our last example for, two more examples for today. We just got to keep working for them. Lots of examples today. So we have two sides. We have a subtraction, so it's going to be a division problem. So log base 3 of x over 5 equals log base 3 of 2. And I divided them because I'm subtracting them. So then we know we have the same base on both sides, so we can use base 3 to get rid of it, and then we have x over 5 equals 2. How do we get rid of a fraction? We multiply by 5 on both sides. Little old school there, equals 10. All right. A lot of this old stuff you guys know. We just got to keep working with the logarithms, and it's just going to take some practice. So here we're dealing with the same base, but we're adding. So we got to multiply. So log base 4 of 5 times x minus 3. I do a double parentheses because I have two parentheses right here. So I'm gonna have to distribute this here in a little bit. Equals log base 4 of x plus 3. Sorry for the writing, guys. So we know this is base 4. So that's going to clean this up. And then once that cleans up, I got to distribute. So let me kind of move this up here, guys. Sorry. 5x minus 15 equals x plus 3. And then we just clean it up. Move the x over, gives me 4x. Move the 15 over, gives me 15 plus 3, which is 18. And then we've got x equals 18 over 4 or 9 over 2. All right, guys, so let's kind of go back to the top here. Here's your main pieces. When you when you add, you're multiplying. When you're dividing, when you're subtracting, you're dividing. When there's a power out front, we move it to the top to create a base log by itself. So as we went through all of these, we practiced all of our different properties. And so today, you're going to work with your properties. This one, you guys are going to divide. So this is going to be 56 divided by n. This one's a multiply, so it's 4x times 5. This has got a coefficient in front. We're going to move that up top. We got to multiply here. We've got some basic ideas that we've been dealing with. Don't forget, move number 7, move this to the top. We're dividing on that one. We're multiplying on this one. So you guys got the right idea, and tomorrow we'll tackle a few more things. So thanks for listening.